tomorrow night to refresh your little memories. Okay, so the first page deals with the shapes. So you do not need to know every single shape that we talked about. There are only 3 shapes that you really need to be aware of that may appear on your test. Okay, so here's your first shape. It says identify this polar equation. Okay, so it's going to want you, it'll have like 4, no, it doesn't have any pictures. You're going to kind of draw the picture for me the best you can. You don't have to like put tick marks or make anything the right size. Just kind of make it look like that. Like a rough sketch, I think is how I wrote it because they told me to make it. So tell me the name of it. Okay. And that's really it. So when I look at this, I see a plus here. If you see a plus or minus involved in anything, that's when you're going to have your limacon. Okay. That's this guy. Remember, he's the one that can have the cardioid, the dimple cardioid, the inner loop, the no loop, all that good stuff, depending on the ratio of his A and B. Okay, so what you're going to want to put, one thing in case you're keeping a separate list, you might want a piece of paper or you might just want to box whatever's going to go on your index card, is that if you have this shape, okay, it's actually plus or minus and it's actually sine or cosine. But for the test, this is the only version of that you would have. So you don't have to worry about all the other 3 choices, okay? You're looking at a limacon, just like this. All right, so in this case, my A is 8 and my B is 8, I notice, okay? The other thing you have to do with the limacon is you have to take the ratio of A over B. That's the other thing you're gonna have to do. And if it equals 1, you have a cardioid. That's the little butt, right, that comes into the sharp point. So this would be what I would put, that's your first thing I would put on your index card, if you're keeping track of like a formula sheet of some type, or you could write it on the back of the study guide, whatever you need. Okay, so what I notice here is that 8 over 8 equals 1, so it's definitely a cardioid. So I've written limacon and I've written cardioid. Now it wants me to draw a little quick sketch. So here's going to be my little quick sketch. It's sine, which means everything is going to be on the y-axis. And it's a plus, which means my little butt comes out and it comes up at the top. Okay, so my nice little sketch is going to look like this. That's all you got to do. Okay, now remember, if you don't want to take up room on your index card with this, you can put this right into your calculator. You can go to mode and you can put radian, polar mode, right? Radian and polar. And then you can put this right in and hit graph and it's going to make that picture for you. And if you are comfortable knowing this picture, then all you have to do is copy it over, tell me it's a limacon and a cardioid. And there you go. Okay, you got it. Does that make sense? Okay, all right, let's try our next one. Next one wants us to identify this equation. This one has an r squared. There's only one picture that has an r squared. That's the limnoscape. Okay, that's an r squared. So here's your limnoscape. Okay, now technically it could be cosine or sine. It could be either one. If it's a sine, it's like a 45-degree angle. If it's cosine, it's horizontal. Yours would be horizontal if you have one, okay? Or you can just put this in your calculator. You can put the positive root and the negative root, right? You would have to put in both if you're gonna graph it in your calculator. You don't have to do that, but if that saves you some index card, you could do that, okay? All right, so your A is your petal length. So in this case, our A is 9. Now this is all the information I would need from you, is that it's a limnoscape, and then you have to draw a picture, but I'm just kind of also telling you what A is, okay? So since it's cosine, it's horizontal on the x-axis. All right, and so it's just like little wings that come out. And that would appear on your calculator if you just graphed it on there if you wanted to. Okay. Remember, if it were sine, it would be like 45 in quadrants 1 and 3. Okay. Sound good? So the name of it and the picture. All right. Last one on here is just r equals, there's not a square, but there's still a 2 or a number in front of theta. This is a rose. Okay. So your actual graph is going to be a cosine in theta. Now, of course, it could be sine in theta, but yours is going to be cosine. So this is how you know it's a rose. Notice this looks a whole heck of a lot like, if you just look at the right side, they're almost identical in how they're set up, but this one's an r squared and this one's an r. That's how you know the difference. So in your calculator, you could just put 7 cosine 2 theta. But really what this means is A is your petal length again. You can kind of ignore that for the picture. But what's important is that N is going to help tell the number of petals. N helps tell the number of petals. So if N is odd, that's the number of petals you have. If N is even, you're going to do 2 times N for your number of petals. Okay, that's important. So what is our N in this case? 2. Okay, 2 is even. So how many petals are we going to have? 4, because it's 2 times 2. All right, and then they're always just evenly spaced. 4 petals is going to look like a cross. Or you can put this in your calculator and see what your petals might look like. Okay. So if you're just going to throw it in the calculator, it's easy enough as long as you remember these weird names. If you're going to try to just remember it from your card, make sure you pay attention to the odd and the even and you know how many petals you have. Is everybody okay with that? Anybody have any questions? You know, I'll take this and rows. That's all you got to have. You would only need to do that if you're not putting it in the calculator. You know, I just thought it might be good review if we talk about it. Okay. Sound good? All right, let's move on to number 2. Now we're going to have to start writing some formulas down. Okay. So number 2 has 3 parts that we want to make sure that we do. Okay. So we're given 2 vectors. Part A, we find the dot product. I'm not really sure how you want to write find the dot product, but remember your dot product, you're going to multiply the x's or the horizontal components. You're going to multiply the y components or the vertical components and then add them together, right, for your dot product. So I'm not really sure if how you want to write that, but it could be something like x1 times x2 plus y1 times y2. I mean, I don't know. You may not need to write anything for dot product. You may be pretty good with that, but just kind of write something to help you remember, or you can use A and B, whatever you want to do. All right, so the first thing we want to do is find the dot product. So we want to find V dot W, okay? So our x1 is 5. Our y1 is 3. Our x2 is 3. And our y2 is -5. Okay, so remember, we're going to take, and it's kind of how I wrote it up here, your first x times your second x plus your first y times your second y. Okay, and what do we get here? For this particular problem, we got 0. You may or may not get 0. It just depends, okay? Because there's a couple different versions. So, all right, that's how you would find your dot product. Everybody good with that? Okay, let's look at B. All right, B wants the angle between the two vectors. Okay, here's your angle between the two vectors. Here's what you need to write for that. Okay, is this middle part right here. So cosine theta equals the dot product of the vectors on top divided by the two magnitudes multiplied together on the bottom. Okay, we'll talk about your magnitude in a minute. Okay, so first step, you have to find the dot product because it's the numerator. Second step, find each magnitude, multiply it together. Then the last step, once you have this, then you do inverse cosine, okay? And vectors like degrees. So you want to be in degree mode. Make a note on that too. Degree mode for this, okay? All right, I don't have magnitude on here, so maybe I ought to add that, okay? So here's what your magnitude of a vector ought to be, okay? It's going to be the square root of x squared plus y squared. Oh, I do have it. It's just way up top on mine. Sorry. So it's kind of like finding R. So here's your magnitude, and you would do it for each vector. And then once you find that answer, you're going to multiply it together. Okay. So here's our angle. Here's our magnitude. Okay. Sound good? All right. Let's go ahead and do that then. Now, because this dot product came out to be 0, what do we expect our angle to be? 90. You would expect your angle to be 90 degrees. How do we know that? Because we have orthogonal vectors. Remember, orthogonal means perpendicular. And orthogonal vectors have a dot product of 0 and they have an angle of 90. So actually, if this were your problem, I wouldn't even waste any more time. I would put B 90 degrees. C, orthogonal, and move on. But let's pretend it's not, and we don't know that, and let's go through the work just in case, okay? So to find cosine theta, I'm gonna have the dot product in the top, okay? And I'm gonna have each magnitude multiplied together in the bottom. Okay, now we know this is gonna come out to be 0 because the top is 0, but let's play it out just to make sure we know how to do this. So to find the magnitude of V, I'm going to take 5 squared plus 3 squared. I'm going to get 25 plus 9. That's the square root of 31. Okay, let's try the magnitude of W. I'm going to take 3 squared plus negative 5 squared. And I'm going to also get the square root of 31. Now that's happening there because this is going to turn out to be the 90 degrees situation here. Okay, so we have cosine theta is 0 over root of 31 times root of 31. That's going to be 0 over 31. Or maybe it was 30, so 34, isn't it? It's fine. Miss Holcomb will just sit up here and do raw math. You just eat your donut. Okay, so 0 divided by 34. Okay. So if I'm in degree mode and I do inverse cosine of 0, I'm going to come up with 90 degrees. Okay, which is what we thought we should get. All right, and then part C wants to know, are the vectors parallel, orthogonal, or neither? Okay, what does my angle have to be parallel? Anybody remember? 180. So they are 180 degrees if they're parallel. They are 90, you can't see that, okay? They are 90 if they're orthogonal, and then they're whatever else if they're neither. So in this case, we are orthogonal. Okay. All right, does that sound okay? Okay. All right. Number 3. Okay, number 3 just wants the magnitude. That's it. How do I know that? Because that's what that means. That means magnitude. So remember, we already have this formula written down. We talked about it already, but there's your formula in case you need it. All right, so it's going to be the square root of 5 squared plus -1 squared. That's going to be 25 plus 1, square root of 26. And I can't reduce that in any way, so I'm done. Okay. So make sure you know what the magnitude means. Make sure you know how to find it. Okay. All right, we're ready for number 4. All right, number 4, I don't really think there's any formula that you need to worry about. I think it's pretty much just like intuitive algebra that you guys would know what to do. It's really all about distributing and then combining your like terms. So just think if there's anything you need to write down for this, but I really can't think of anything that you would. Here's V, here's W. It wants you to multiply V by 6, so you'll distribute 6 through it. Distribute 7 through W, and then add them together. That's what it wants you to do, okay? So I'm gonna have a 6 in front of the little packet that I made of V. I'm gonna add 7 times the little packet I made of W. Okay. And then I'm just gonna clean it up. So 42I minus 54J minus 42I plus 28J. Now this one's doing something weird, as you can tell, and our I components are going to cancel. Your I components won't. You're going to have an I and a J, but this one just happened to not. Anyway, when I clean it up, I get negative 26J. There we go. And that's your answer. Okay, so I don't really think there's anything you need to write down for that one. Just don't panic when you see it, right? Okay, number 5 is just, we already talked about this, but let's just talk about it again and let's add a little piece to it. Everybody good with this one? Did I change it? Okay. All right, so let's look at 5. 5 says if 2 non-zero vectors V and W are orthogonal, perpendicular, what's the angle between them? We already talked about that. What is the angle of 2 orthogonal vectors? It's 90 degrees in degrees. I think on the test, if I'm not mistaken, they're going to ask you in radians. Please read the directions. Do not just put 90 and move on. I know vectors like degrees, but so what would you put for radians? What's 90 degrees in radians? Pi over 2. So just make sure, it wouldn't hurt, just put both, then you don't have to worry about it. Okay. All right, let's look at number 6. Okay, so number 6 wants you to write the vector V in this form. It gives you the magnitude and it gives you alpha. You know, sometimes they use alpha for vectors instead of theta. Okay, let's find the formula that you're going to need for that little guy. Your formula is going to be the magnitude times cosine of alpha times I plus sine of alpha times J. And you're going to need to take both of these values and find the point on your unit circle. So you're going to need unit circle for this test, big time. That's why I'm trying to give you options to not use up your index card on the unit, you know, on other stuff that you may not need, because you may need a whole side for your unit circle. It just depends. Okay. All right. So here we go. This is just plugging it right in and using the unit circle. So I'm going to have the magnitude, which is 20, times the cosine of 120 degrees I, plus sine of 120 degrees J. Okay, everybody see I just plugged in what I had. That's all I did. And now I'm going to go to my unit circle. Okay, I'm going to try to just squeeze it in right here. All right, here's 120 degrees. Cosine of 120 is -1/2. Sine of 120 is √3/2. So I'm just going to replace cosine of 120 with -1/2. Now you still have I, because look, this is the form you want. So you have to keep I and J. You want to see it at the end. Plus sine of 120 is √3/2 J. Okay, so all I did was plug it in right off of there. All right, now I'm going to clean it up. I'm going to distribute my 20 through there. It's going to give me a -10I plus 10√3J. And there's my answer. Okay. All right, if you want to see that a little bit better, that's going to be -20/2I plus 20√3/2J. If you want to see that little in-between step, I just multiplied it by the numerators, and then this reduces to -10, and this reduces to 10√3. Okay. Sound good? All right, let me know if you have a question. Okay, number 7. The question here gets to be confusing because it looks like it's I don't know, it looks like there isn't a question. What they want you to find is letter A. That's what they're wanting you to find, not find a something something. It's find A, you know, so it's
Find a so.
yeah, find a so, no, find A. So, okay, that the vectors, this guy and this guy, are orthogonal. So we're back to orthogonal again. Okay, orthogonal has an angle of 90 degrees, and orthogonal has a dot product of what? 0. That's what you're going to want to use here. V dot W is supposed to be 0. So let's do a dot product of this guy. Okay, so dot product, remember, is going to be your x component, first x, times your second x, plus your first y times your second y. Now, what's my first y going to be? -A, because we don't know yet. So we just put in what we had. Okay, now we also know what we just said over here, our dot product is supposed to be 0. So we're going to set the whole thing equal to 0, and then we just solve for A. It turns into algebra. So 1 times -2 is -2. What's -A times -3? 3A. Okay, now we're just solving. So we're going to add 2 to the other side. We get 2 equals 3A. We're going to divide by 3. And we get 2/3. Okay. So if you can actually read the directions, you'll be fine. You know, they don't confuse you. But got to know to set it equal to 0. All right. We ready for 8? I'm good. Okay, 8 tells you that this is the initial point P. This is the terminal point Q. So we start at P, we end at Q. Write the vector V in this form to make it a position vector. So a position vector is just going to be final minus initial. I guess I should have written terminal minus initial, but you guys get the picture. That's it. So I'm just subtracting. That's all it is. Okay, but make sure you know you're going to have to do Q minus P. You have to do that second one first. That's the key. Don't subtract it the other way around. Okay, final or terminal minus initial. All right, be careful because you know with subtraction, there's a secret step. you're actually distributing a negative to the guy in the back, right? So I'm going to have here, all right, let me see here. What did I do? No, I don't have to do that. My bad. Okay, so I'm going to have B equals, okay, I'm going to have 5 minus negative 6. I'm sorry, guys. I was thinking of a different problem. I. Okay, so I'm just subtracting my little I components. And then I'm going to do negative 7 minus negative 8, subtract my J component. So just keep track of your positive and negatives. I was thinking of a different problem. Sorry about that. Okay. All right, so 5 minus negative 6 is 11i. Negative 7 minus negative 8 is plus 1j, but you just put j. I'll take 1j if you want, but you don't have to. There's your position vector. Good? Any questions? Okay, we're moving right along. All right, we got a new formula here then on number 9. Okay. All right, so number 9 wants you to find the direction angle of vector v. Okay, so here he is. All right, so this negative 5 root of 3 is your x. Positive 5 is your y. The formula that you want for your direction angle is tan theta, or you can say tan alpha. You know, sometimes they use alpha, sometimes they use theta, y over x. But the key is you must know what quadrant you're in. That's the key. You have to know what quadrant you're in. Okay, so let's think about this. Negative x, okay, that's this way. Positive y, that's this way. What quadrant am I in? 2. Does that make sense? Negative x, positive y, I'm in quadrant 2. Okay. All right, because you have to be able to narrow it down. All right, and you're going to use your unit circle. Yours will be on the unit circle. You will not have to deal with reference angles on this test. Yours are going to be right there for every question. All right, so here we go. Tan theta, all right, is going to be 5 over negative 5 root of 3. It's going to be negative 1 over the root of 3. Is everybody good with that? Now we take our unit circle in here, and we said we're in quadrant 2, so we're only looking in quadrant 2, just right here. Our theta is going to be one of these 3 numbers, okay? We want the theta where tangent would be negative 1 over root of 3. Okay, so tangent's y over x. It's not going to be this one because that would be negative 1. So if I want 1 over negative 1 over root of 3, and it's got to be y over x, which one do we think it's going to be? It's going to have to be 150 because look at our x's and our y's. 1/2 over negative root of 3 over 2 is going to make that. So let's just look at that. Okay, that's 150's point. So if I then take y over x, my 2's cancel, and I get negative 1 under root of 3, which is exactly what I wanted. So that means theta is 150 degrees. What if I wanted my root of 3, my square root of 3 in the top instead of the bottom? Then it would be 120, right? What if my tangent equaled negative 1? It would be 135 because y over x would give me the negative 1. Okay, that you got a lot kind of going on there. You got to find your quadrant, then you got to take the y over x and make it equal whatever your tan theta equals, and then that's how you know it's your theta. Okay, is that all right with everyone? See how we got that? Okay. All right. Let me know if it's not. Good. Okay. All right. So 10, the letters X and Y represent rectangular coordinates. Write the given equation using polar coordinates. So remember, polar coordinates are R and theta. When they tell you polar coordinates, you do not want X or Y. They better both be gone. And you better either have an R or a theta or both. So there's a trick to doing this always, to going both directions. Okay, so here are the equations you need to make sure that you have written down. Okay, these four. Make sure you have these written down. That's going to help you go back and forth between polar and rectangular quadrants. So this is what X equals. This is what Y equals. We already talked about this one. We have to know our quadrant. And then here we have R squared equals X squared plus Y squared, but we can also find the square root of that to just get R if we need to. Okay, so these are the four that's going to let you go back and forth between rectangular and polar. That's all you can use. That's your stuff right there. It's very dramatic. And I just said that's all you can use. And then there was music. Okay. All right. Does everyone, you want to, is this okay? Can I move it? Okay. All right. So here we go. What I notice here immediately is I have an X squared plus a Y squared. Now I have sevens out in front. I'm not worried about them. If you have an X squared and a Y squared, guess what equation you're using? This dude. Everybody see that? You already have X squared plus Y squared. Okay. Well, let's deal with these sevens. Okay. Fortunately, they each have a 7, which means 7 is the GCF. Remember that good old guy from algebra? So if I pull out a 7 from each term, look at there. Then what can I replace X squared plus Y squared with? R squared. Perfect. So what you need for this guy, we already kind of talked about it, is this. That's what you need for that. Okay. All right. Now we want to solve for R squared. You can leave him squared. That's what we're solving for. And that's going to be your answer. Okay. So that's one of the types of problems you're going to have. Pull out a GCF, replace it with R squared, and then solve for R squared. Done. Okay. All right. Now we got another one. This is a polar equation. It wants us to transform it into a rectangular equation. So get rid of R and theta. Now, most of you are going to stop reading there and only get half points, but the rest of you are going to see, then identify it. What kind of graph is that? Then graph it. It'll be so easy. It's just a line. You just have to tell what kind of line it is. All right, so here we go. What I notice is on one side, I have R sine theta. Okay, I go to my equations. Do you see R sine theta? Bam, there he is. So what am I going to replace the left side with? Y. You guys are just bundles of excitement. So I'm going to replace R sine theta with Y. And then I'm done. That's it. It's meant to be easy. Okay, Y equals 5. What is that? What kind of line is that? Horizontal. You knew it was one of these or these. Okay, just think of it as, okay, and even if you have to graph it first before you realize what kind of sign it is. Oh, I messed that. I got so excited because y'all aren't excited and I got my thing. Okay, so Y equals 5. So you'll have a little graph, just 1, 2, 3, 4, 5. Okay, it's got to go this way to cross Y equals 5. So if it has to cross the Y axis, then it's got to be horizontal. You're going to need to write horizontal line. So be careful on this. It's 3 parts. Give me the equation. Tell me what it is and graph it. You're going to need all 3 of these guys. Okay. Okay. Sound good? All right, let's try another equation. You got 2 more equations where we're using those four formulas. Okay, 12 and 13. So here's 12. Now 12 also tells you you don't have to identify or graph. So I'm sorry about that. Get rid of that. All you have to do here is write the equation. That's it. Okay. All right, so we want to transform this guy into an equation with rectangular coordinates. Okay, this one's a little tricky. Let's think about this. I have r on one side. Well, I mean, I guess I could replace it with a root of x squared and y squared, but that's not very elegant. Okay, over here on the right, I have sine theta. Well, I don't really have sine theta. I have r sine theta. So, gosh, it would really be nice if this side were r squared. And it would be really nice if this side were r sine theta. So what could I do to each side to make my life a little easier? I could multiply both sides by r. That would make my life a lot easier. If this were r squared, boom, x squared plus y squared. If this were r sine theta, boom, it's y. Everybody see that? It's just missing one tiny little component and your life is a lot easier. So if I multiply r by r, I get r squared. And if I multiply an r over here, I'm going to stick it in front of sine theta because then it turns it into y. And things sure are a lot nicer. Okay, that's all I did was use this one and this one. Okay. All right, well, we know r squared is x squared plus y squared. 7 is just 7. And we know r sine theta is y. Okay, for a rectangular equation, they like you to move everybody to one side because this guy's actually a circle. So I'm just gonna scooch him over and there we go. You don't have to tell me it's a circle and you don't have to graph it. You just leave it alone. Okay. All right, sound good? That was the trickiest one. All right, 13 is meant to be super easy. It's just like number 11. It's kind of the little brother to number 11. Okay, now here you are going to have to write the equation, identify the equation, and graph the equation. So you have 3 things you have to do there. All right, well, according to this guy, do we see anything that looks like r cosine theta? Yeah, we got x. I don't think I have to do anything. I'm just going to replace it with x. Done. Okay, that's why he's the brother to the horizontal line. What kind of line is this dude? He's vertical. If you're not sure if he's vertical, graph him first. He's got to go through x equals -4. So the only way to get through x equals -4 is a vertical line. And there you go. Okay. All right. I'm moving right along. Good on that one? Okay. 14, all you have to do is plot a point. That's it. So here's your little polar graph, okay? So remember, this is r theta. That's what that means. And you graph theta first. This is where your unit circle is going to come in handy for you, okay? So I need to graph -5 pi over 3 first. I need to put the line on there. I need to put a pole, okay? I mean, a polar axis. All right, so where in the heck is +5 pi over 3, first of all? All right, +5 pi over 3 is down here. He's 300 degrees. So to go positive, I start here and I go all the way around to quadrant 4, 300 degrees. All right, I want -5 pi over 3. So -5 pi over 3, I'm going to go all the way around this way to here, 60 degrees. Everybody agree with that? This line right here is -5 pi over 3. Okay, so there's not really one here. Just draw one. I know it's kind of weird. We'll just say it's this dude. I just kind of put one next to it. Just get me in the right quadrant. I don't care if you're, get me in the right quadrant, you're good to go. I don't need to know exactly where you're supposed to be. All right, so this is going to be negative 5 pi over 3. That's what he is. All right, now, I don't know if you remember this, but every circle is a radius of 1. Okay, so let's see, I kind of need some more circles than what I got in here. I'm going to draw a circle right in here. Ooh, that's not a radius of 1, but we could pretend. Okay, so there would be 1. This would be 2. Let's say this guy's 3. And this big guy on the outside is 4. See where I'm going with this? Okay, now my R is negative 4. Okay, so I'm starting at the origin. Negative 4. Am I allowed to just go 1, 2, 3, 4 and stick him right here? No, where is negative 4 hopping? Backwards. So I don't even want this line, which means I got to draw a dotted line out the back of him. Okay. And then I'm going to have to hop 1, 2, 3, 4 out that way. And that's my point. Okay. So just be careful, draw your line. If your R is positive, fantastic. Hop forward on the solid line. If your R is negative, dash it out the back and hop backwards however many circles. And if you don't like my circles, you can draw some littler circles, different circles in there, that's fine. Just make sure I can see that it's clearly 1, 2, 3, 4 out the back. Okay, sound good? Okay, any questions on him? Trucking right along. All right, 15 and 16 on the next page are the same. 16 would be good for you to practice, but 15 is going to be more like your test question. So we're going to do 15, but if you feel like you need a little more practice, you can do 16. The reason I say that 16 is a little strange is because you won't have one of the components when you're done. When all is said and done, you won't have 2 pieces. Your first piece is missing. So that's why I just say it's kind of strange. All right, write the complex number in rectangular form. Now we know this is a complex number because this guy has an I. This is not a vector in polar form. Remember, a vector in polar form, I think I have it on here. Let me go back to what we did before. Okay, a vector in polar form looked like this, right? It had an I and a J. That's a vector in polar form. This is complex form. This is a complex number. This is not a vector. This is not a magnitude. This is not a vector. Complex form, remember from algebra, is this. This is a real number in the front. This is an imaginary number in the back. Okay, so it's different, a little different. Okay. So what we want to do is write it in rectangular form, which is this. I just gave it to you. That's what that guy is. Okay. But here in trig, this is algebra rectangular form. I guess I should tell you, write it like this instead. This is trig rectangular form with X's and Y's. So sorry, I need to stick with trig. Okay. Well, it turns out these formulas we just looked at, those are the formulas you need. That's it. Okay. So this is really of the form R, okay, cosine theta plus I sine theta. That's the form that it's currently in. You're going to take X using that, and you're going to take Y using this. Okay, so this is for complex. This is complex form. It's not a magnitude in front. It's not an I and a J vector. It's just like this. And this is what you're going to use to get it into rectangular. Okay. All right, so my R is 14 and my theta is 5 pi over 3. Okay, so let's find our X. Our X is going to be 14 times cosine of 5 pi over 3. All right, we are going to go to the unit circle and make this a little better. Okay, 5 pi over 3. Let's see, here he is down here. He's 300. My cosine is 1/2 and my sine is negative root of 3 over 2. Okay, so I'm going to have 14 times 1/2. My x component is going to be 7. Now I'm going to find y. 14 times the sine of 5 pi over 3. All right, we said the sine of 5 pi over 3 is negative root of 3 over 2. All right, if you want to clean that up, if you want to kind of baby step it in, you certainly can. There it is. I just put it in the numerator with the root of 3, and then you can reduce in the bottom, or you can jump right on in like that. And then your final answer is going to be 7 minus 7 root of 3 I. Don't forget that I in the back. He's a complex number. That part is imaginary. Remember, a complex is real and imaginary. All right, so if you do the same thing with 16, what you're going to find is that your x component comes out to be 0. So the answer to number 16 is just negative 6i, because there is no x. Just in case you want to practice, but yours won't be like that. Okay. Last one is 17. He's a long one. All right, dealing with complex numbers. Is everybody okay with this guy? All right. Okay. All right, let's look at 17. Okay, again, read the whole thing. Please read the whole thing. I tried to, when I went through, like bold some words so you would see it, but okay, we have 3 things we need to do. First thing we're going to do is we're going to plot the number. That just means a dot. You're going to put a dot on there. Okay. Then we're going to write it in polar form, and then you're going to write it in exponential form. Let's figure out what all these things are. All right, let me find my little formula sheet here. Okay, we can plot. That's going to be easy enough. This says imaginary axis. That's what that's supposed to say. This is real, R-E. Okay, so we'll get to that in a minute. All right, polar form. Okay, your polar form is going to be R cosine theta plus I sine theta. Okay. Your exponential form is R e to the I theta. Okay. And then we already know how to get those thetas and those R's. They're just going to be from these 4 up here that we were messing around with earlier. Okay, we'll do that down here, but I just kind of wanted to get that out of the way first. Okay, so the real portion of this is 12 root of 3. All right, just do the best you can. If you put 12 root of 3 in your calculator, you get 20.8. Okay, just give me something that looks between 20 and 21, or you can give me 21. I don't even care. Okay, just give me something that looks kind of right. Now I know this is stinky because that's not even on the graph, Ms. Holcomb. This only goes to 9. So just, whatever, just do the best you can. So we know we're like way over here. Okay, let's say that this is 20 over here. Let's say this is 20.8 way out here. 20.8, okay. Yours will be so nice. You'll have your whole graph can fit. It'll be really clear. All right, then my imaginary portion is negative 12. So am I going to go up or down? I'm going to go down. And we're going to say he's about there. How about that? Looks good to me. You plotted it. Sound good? You got it in the right quadrant. It's close enough. You're going to have really pretty grid lines. There you go. Everyone okay plotting it? Okay. Now we got to pay attention because we have a theta. What quadrant is that in? Quad 4. We have to take note of that when we go to get our theta. Okay, here we go. So this tells us also that we want radians because I see pies. And it actually uses the word. Type any angle, measure in radians. All right, so here are the two formulas that I want to find. So I know my x is 12 root of 3, and I know my y is negative 12. I also know I'm in quad 4. Okay, now I'm ready to scooch up. That's all the information I need. Okay, okay, I need to get an r. So if we go to our formula sheet, r is the square root of x squared plus y squared. Okay, so the square root of x squared plus y squared. And you're just going to do the best you can in here. We don't want any decimals. Okay, so 12 root of 3 squared, you can put that all in parentheses in your calculator with a little square on the outside. Otherwise, you can do 12 squared, which is 144, root of 3 squared, which is 3, 144 times 3, you get 432. Negative 12 squared is 144. And I got root of 576. Okay, and then before you panic, try it. Turns out root of 576 is a lovely little 24. We came out just fine. Okay. All right, so we have r. Next thing we need is theta. Tan theta is y over x. So negative 12 over 12 root of 3. We need to find a theta in quadrant 4 where tangent, meaning y over x, is equal to negative 1 over root of 3. So root of 3 is in the bottom, which means root of 3 needs to be in your x component, right, to get it on the bottom. So quadrant 4, I need root of 3 in the x to get it on the bottom. I see an 11 pi over 6. Everybody agree with that? It's got to be either 5 pi over 3 or 11 pi over 6. And when you take y over x, that's going to put root of 3 in the bottom. Okay. So that is 11 pi over 6. All right. I already wrote your formulas for you up here. We're just going to plug them right in. And then we're done. You leave them just like that. You don't want them any other way. Okay. So my polar form is z equals 24 times cosine of 11 pi over 6 plus I sine 11 pi over 6. If you I get a lot of students that'll get it right here and then they'll go, oh, now I'm going to go to my unit circle and now I'm going to plug these in and then I'm going to multiply by 24 and clean it up. And guess what they get when they do that? This, we knew that. That's what you started with, right? So stop. This is polar form, okay? All right, now we also need exponential form. So it's r times e to the I, and then you put theta right beside your I, and you're done. So you don't have any division or multiplication of polar forms. You don't have to deconstruct any vectors. You don't have any of those really long, complicated problems. It's really just a real brief overview because your final exam's next week, and you're going to have those on your final exam. Okay, so that is it. Now you are going to have 2 bonus questions, but neither one of them are trig. They're both just riddles. But then we will start reviewing on Friday for the final. Okay, and I will